let's talk about using functions in Matlab. Matlab is absolutely amazing because it has all, well, not all, but like pretty much all the functions you could ever possibly want out of a programming language. So like let's say that I wanted to sort some numbers. So I'm like, okay, well here's some numbers, 3, 4, and well that's not a 4, but 2 and 1. All right, so there's my numbers and I want to sort them. I wonder what the Matlab function is for sort. Let me try sort. Hot damn, look at that. I have sorted matrix. It's amazing. So we really, really, really love Matlab specifically because it has just a ton of really fantastic built-in functions. So let's take a look. It's really cool. So here's some pretty common functions. So like the square root. So if I want to find the square root of a function, blah, square root of a. And there I go. So I have a is 9, the square root of a is 3. Now, just kind of an FYI, the square root function, in and of itself, even in regular math, if you just say square root, it's the plus version. If you have x squared equals 9, then x could be plus or minus 5, or wait, 3. But if you say that x is equal to the square root of 9, it always means positive 3. So there. Let's see, what else do we have? So what's really cool about it is not only can I take the square root of just a regular number, but say I want to take the square root of a whole bunch of, you know, like other numbers. Skip like that. So if I had a row of numbers, I can take the square root and it will come back. If I want to take the square root of a vector, I can do that. And I'm just using pretty numbers. You don't have to use pretty numbers. So see, if I ask for the square root of 1, 4, 9, and then 16, 25, 36, it gives me 1, 2, 3, 4, 5, 6. And of course you don't have to do this in the right order. You don't have to actually have real numbers. And there you go. This is absolutely fantastic. So it gives me answers in the complex plane, which really shouldn't figure or confuse you or upset you too much. So there you go. Alrighty, let's see what else we're going to talk about. You can do all kinds of stuff. So the square root function has one input and one output. You probably didn't even notice when you were doing it, and you might say, well, it's got like 6 different outputs here, but they're not really 6 different outputs. That is exactly one output, and it's called blah. So if I want to use it later, there's blah. Okay, so that's one variable. There's exactly one input, and again, you say, but I inputted 6 numbers. No, you didn't. You inputted one matrix. So you inputted, I don't know if that's a real word, one matrix as an input. Well, I just wrote that. How about one matrix as an input, one matrix as an output. All right, so that's pretty standard. You get one input, one output. Now, if I wanted, there are other Matlab functions that have multiple inputs. There are some that have multiple outputs. There are some that have multiple inputs and multiple outputs. So we've already kind of looked at one that has multiple inputs. I'm just retyping this from the other page. So we used like linspace. So we had linspace starting from 1, ending at 7, give me 6, let me give you, I don't know, 4 elements. So, oh, that was kind of pretty. I was trying to make it not pretty, but I can't help it. All right, so there we go. So that's linspace. Linspace actually has 3 inputs. So the first, the end, and the number of elements. So start, so the start number, the end number, and the number of elements. So we actually have multiple inputs for linspace. Let's see, something with multiple outputs. Ooh, size. All right, so multiple outputs. I want to use, I'm going to recall this B so I can continue to use it. So if I want to say blah is equal to the size of A, all right? So this is actually kind of has 2 outputs. I can either ask for one output from this. Now all these functions are different. This is kind of a weird example, but see right now it gives me one output, and if I look at blah over in my workspace, it is, let me see if I can give you the size. Okay, I don't care about that other stuff right now. But it says it's a 1 by 5 or a 1 by 2 matrix. So blah says 2 and 3, it's a 1 by 2 matrix. So this is using it as one output. So we'll do this. Okay, then I can say this, or I can say it has 2 outputs, and I can say specifically give me yellow, blue, and for the size of A again, and it will actually give me two outputs, yellow and blue. Kind of neat. Where are you yelling at me? Oh, best practice, sure, best practice. There you go. Anyway, so this is an example of multiple outputs. To get multiple outputs out of a function, you would use brackets, and then you would have the first output, and then you'd have the second output. And that's how you get the two outputs from a size matrix. In general, I'll go ahead and write this out. In general, if something has multiple outputs, but you only ask for one output, it'll give you just the first one. And it won't warn you or anything. Okay. So that's kind of important to know. So if something has multiple outputs, if you only ask for one of them, you'll only get the first output back. So a really good example of that is the max function. So let me give you something like this. I kind of want to do it like this. All right. So 8, 3, 9, and 2. Now, if I just say whatever equals the max of B, what do you think the max does? Now, you don't have to be like super smart to be like, max is going to give me the max value, and to be like, yay, you're right, look, it gives me the max value. So there you go, there's the max value. So in this case, even though max actually has multiple outputs, you don't know this, and you just ask for the first one, and it acts exactly like you would want it to, which is actually kind of nice because it means you can use functions without knowing the full power of what you're getting into. But you could try this. You could say, jumble suppose. So now I'm going to say, hey, max function, give me two outputs. Okay, so again, and it's going to yell at me, it likes to see commas. You don't have to have commas, it's just a best practice. But I put it into my little square brackets and I say, give me one output, actually give me two outputs. Call the first output chumble, the second one spuzz, and then you've got the max of B. Now you look at this output and you go, okay, wait, where'd that 9 and 3 come from? With the size, that makes sense because it was like rows and columns, but here it's 9 and 3. What can that possibly mean? So that 3 doesn't seem like it should be that 3 because that's not a max, that's not a min, it's not an average, so what's up? So here's where Matlab is amazing because you're like, I don't really know what I did. Help max. Now, if you type help and then a function name, it's going to turn purple, and whenever it turns purple, that means, hey, seriously, this is awesome. You should hit enter because there's more information. All right, so I'm going to hit help max, and I'm going to scroll up, and it's going to give you a whole lot of information. So obviously, max is the largest element in max, and it does take a little bit of practice to actually get to interpret this. But here's what we're looking for. Here it's got two outputs. Okay, so y and I. So you have to remember this because it's going to refer to it later. Returns the indices of the maximum value in vector I. That's weird. Why does it say that? Well, it's an index basically. If the it's yeah, okay. So basically, I don't know if this is always that helpful. Sometimes if you type or if you click on the doc max, you can get a little bit better information. We'll see. So here's that. It says the same thing. Oh, so here's some examples. That's actually not that helpful. So, sometimes you win some, you lose some. And you might have read that and go, well, I clearly understand what that means. But maybe you read through it and said, no, I didn't really know what that means. Or maybe you've already figured it out. So I'm going to show you again what it gives me. So I get a 9 and a 3. Now, hopefully some part of you started to realize that this is 1, 2, 3. So 9 is actually the third element. Why would I ever care? Trust me. Everything that's a function is in Matlab because at some point someone was like, I really need this information. So if you want to play around with this, you can change it. So now I'm going to make 12 my max. So I would hope that if I've interpreted this correctly, that the max would be 12 and the position would be 4. And that's exactly what happens. The max is 12, the position is 4. Something that's kind of neat, and this is kind of off topic, but a little bit, I don't know, it's fun. So let's say I've got a bunch of 9s and I run this again, it's still going to give me the first one. So it's going to say, okay, well, the max is 9. The first place that I see a 9 is in number 3 now. So the max isn't necessarily going to tell you every single time the max shows up, but it will tell you the first time the max shows up. So that's kind of cool, but this is an example of a function that has two outputs. Let's see, what else do we have? Size, max, oh, there we go. So let's play with max a little bit more. I don't know, make up I don't know, just make up something. I like 9s apparently. 4 and 3 and 7 and 1 and 5 and 2. Alright, so now let's do, and I'm going to rewrite jumble spells because it's just fun to say. I'm going to find the max of C. So it's always good to, and kind of fun, you know, whenever you're lonely and stuff, to try to anticipate what a function's going to do before you actually run it. So think about what you think it's going to do. Honestly, you might not have enough experience with Matlab yet to really get an idea. But as you look, you're going to get 4 outputs. And this might be a little bit weird because you're like, well, this isn't really, you know, what's going on? Where are these numbers coming from? So you want to think about taking these numbers in pairs. So I have 9 and the index is 2. And probably without too much effort, you could kind of make the correlation of the fact, well, I have 4 answers and I have 4 columns. And you're like, oh, okay, I see what's going on. So basically what I'm telling you, or what the max function is telling you, is that the 9 is in the second spot in the first column. And it's the max. The max of the second column is 3, so there's my 3, and it's in the first position. Then I have 9, which is also in the first position, and then I have 3 again, which is in the second position. So we're going to see this a lot. Matlab likes to compare things by columns. So that's kind of neat. But anyway, this would be an example of something having multiple outputs. Let's see, what else do we want to talk about? Functions. Ooh, yay! All right. So just to kind of finish off our idea about functions, if for some reason I just cared about the max, so let's go back to just you know, stuff equals the max of C. So remember that if I'm looking at this, then that's just going to give me the max for each column. So if I run this, all right, I've got 9, 3, 9, and 3. So that makes sense. I'm going to do I don't know what I want to do. I'm just going to recopy this because I want to clear stuff out. I've got too much going on. All right, so there we go. Cleared everything out. Then there's my max. Max of each column. Now, if I want to be really, really obnoxious, for no reason in particular, I could actually take the square root of the max. Well, that's kind of goofy. I don't know why I would, but you can actually nest functions. And so you probably did this in like a college algebra class or regular or something where you like, they would call it like f of g of x or g of f of x or g of x or f of x, and if g of f of x is equal to f of g of x, then they're inverses of each other. Well, actually, only if they both equal x. But anyway, well, yeah. Okay, so, well, yeah, I think so. Anyway, so this is just like nested functions. So I have the square root of the max. Now, square root of the max is kind of goofy, but what I could do, which probably would make more sense, is I could ask for the max of the max. And let's kind of mess up some of these numbers a little bit. So let's do, I don't know, let's call this one a, why is it so hard to come up with numbers? I'll leave that as a 9. But if I ask for the max of the max, so if I just ask for the, I'm going to get this eventually. If I ask for the max of C, I'll get those 4 values per column. But then think about what it's going to do if I nest it, is it's then going to go through here and it's going to pull off the max value of those. Now, let's go ahead and make one of these over to a 2. So I could actually, if I wanted, so this is how you know. So if you really think you've got this, what you should try to do is anticipate what the output of each one of these functions would be. So I could do the max of the min. I could do the min of the min, and we didn't actually talk about what min does, but I'm assuming at this point you could probably figure it out. The max of the min of C. So I strongly recommend that you just take a minute and actually, you know, like, I don't want to say work it out on paper, or yeah, work it out on paper. So go through here and think about, okay, what's going to do? The first thing that's going to happen, just like in regular math, we work from the inside out. So we look at C, and then we're going to look at the max of the C, and that you can imagine that's going to give it by columns, and I find the max of those values. All right, then I'm going to find the min of those values. All right, then I'm going to find the min, so the min by each column, and then I'm going to find the min of each of those columns, or each of all of that together. So you should probably try to go ahead and think about this. So if I have the max of C, I expect the max of C, so the max of the first column is 8, the max of the second column is 3, then 9, and then 2. So I would expect the max of that to be 9. Right? You kind of see maybe what I'm doing? If you think you got it, go ahead and pause it and give it a shot. So this is going to be the same thing because it's the same thing on the inside. So this is what I'm going to get whenever I ask for the max of C. So now if I ask for the min, I would get 2. All right, now I'm looking for the min of the minimum of C. So the minimum in the first column is a 6, the minimum in the next column is a 2. Oops. Sorry, the minimum in the next one's a 1. Then the minimum is a 4, and then the minimum is a 1 again. So if I'm asking for the minimum of the minimum, I'm going to get a 1. And then if I'm asking for the max, of the minimum, then I would expect to get 6. All right, so let's see if that's what happens. I've got 9, 2, 1, and 6. It's exactly what I want. So if you can understand the concept of nested functions, you'll be great. But again, the purpose of this was kind of to give you an idea of nested functions, of the fact that you can have multiple inputs, multiple outputs. You can actually have things with no inputs, no outputs, and all that's kind of fun.